Business, Energy and Industrial Strategy Select Committee for our first hearing of our new inquiry on semiconductors in the UK, looking at opportunities and vulnerabilities to the sector. And in our first panel this morning, we're delighted to welcome Martin McHugh, the CEO of the Compound Semiconductor Application Catapult, and his colleagues Alistair McGibbon, who's an industry expert, and Dr. Andy Sellers, who's the Strategic Development Director. Good morning to all three of you on the screen. Martin McHugh, if I can come to you first. I think this is probably the first time a select committee, certainly recently, has looked at this issue, and we've been getting our head around the difference between silicon chips and compound semiconductors. And my understanding is silicon chips have silicon in them, that should probably be obvious, and compounds have silicon and some other materials. And I understand that in the UK we're particularly strong in the compound semiconductor sector. If all of that makes sense, please can you say so, and also explain what that means for the UK from its strategic position within these often complicated global supply chains.
Okay, thank you very much. So your description of a semiconductor as a single material, mainly silicon, is correct. It's what's driven the electronic system integration for the last 30 or 40 years. It's probably been the main technology for miniaturization and for everything that we've got used to in our electronic world. Compound semiconductors, as the name implies, is actually made up of two materials. A common one would be silicon and carbide, called silicon carbide. That's a particularly interesting combination of materials because it has the ability to handle far more power than conventional semiconductors, so it would be extremely useful in furthering the development of electric vehicles, for instance. Other compound semiconductors, GaN technology, would be useful for taking us from 5G to 6G. The other key advantage of compound semiconductors is that they can actually detect and emit light, which makes them very useful for sensing applications in future robotics and AI applications. So the UK typically, as it is often an early adopter and an earlier starter in technology investment, the UK has actually spent nearly 800 million in research for compound semiconductors, and actually has a pretty good leading position in the world in terms of research and development. And obviously this catapult is actually based in one of the only compound semiconductor cluster in the world at the moment. So the purpose of the catapult, to answer your question about the supply chain, is really to help that transition of the research into industry, hence we're called an applications catapult, and to actually help companies make their products more competitive by adopting compound semiconductors. So we're at that turning point now where it's critical that the various supply chains come together, the industry comes together, and we actually take that incredible amount of research that the UK has built up over the last 15 to 20 years and make sure that's commercialised.
Thank you very much. Mark Pawsey, please.
Thank you, Chair. Just following on from that point, if I may, you told us that we spent £800 million on research. We're in a leading position. How many people know that?
That's a very good question. I think within the UK, it's well understood that we are leading researcher in terms of compound semiconductors. What we're doing at the moment ourselves and other clusters within the UK are working on getting that message out now about this particular cluster being the only one that's actually in the world. But it's something that we have to work on, something that the UK itself has to come to grips with and promote.
If we have that lead, is it your assessment that government understand that? Do decision makers in the building we're in today know that we've got this leading position? Because all we hear about in respect of semiconductors is the problems caused by shortages.
Right. So the compound semiconductors are a particular field within the broader framework of semiconductors. So most of the supply chain shortages at the moment, all of them are actually connected with the broader semiconductor market. So compound semiconductors hasn't got to the point yet where it's actually caught up in the supply chain issue.
Okay, but how do we get to have better understanding here of the valuable role that the work you're doing and this particular sector has? Because we don't know that at the moment.
No. So that's part of the role of the catapult, is to actually get those messages to the market. You know, it's a good reason why we wanted to be part of this select committee, is to get the visibility of compound semiconductors into a wider audience.
Okay, and does industry more broadly understand the lead we have in this field?
The industry that's actually involved in compound semiconductors...
No, I'm talking about the people who would actually use the semiconductors. Do they know that we're ahead in this area?
It's a mixed picture, if I'm honest with you. So those that are actually using compound semiconductors realise that we are ahead. On the periphery, then, we have to extend that message to, and that's part of the role of the catapult, to actually encourage people to adopt the use of compound semiconductors to make their products more competitive. Okay,
and how can you go about doing that? How can we take advantage of this lead that you say we have?
I'd like to invite Andy, our Strategic Development Director. I think is actually in quite a good position to answer that question, if that's okay with you.
Thank you.
Yeah, thanks.
Thank you, Martin, and thank you for the opportunity to address the committee. You're quite right. So Martin has indicated that the UK has invested over £800 million in the research of compound semiconductors through the universities, and the role of the catapult is to translate that research into actual applications. Now, we have, and in terms of the recognition, Innovate UK has recognised our leading position, and Innovate UK has established the catapult in order to drive that role. I think how we can help do this is to look at the large markets that we're looking to address. So the net zero market of vehicle electrification and smart energy grids is one of the large markets. 5G, 6G communications, satellite communications, and quantum technologies. By identifying these large markets, we can build the supply chains and build the UK semiconductor industry to supply those supply chains. And I think it was a great opportunity. I think Innovate UK are certainly recognising these programmes. Innovate UK, the UK's innovation agency, has funded the quantum programme very, very extensively. And it's these kind of programmes which are bringing industry together to translate the work from early stage research out to commercial applications. Okay, and is there an everyday product that we will use, that we could say has a UK-based conductor in it? There certainly is, yes. So if I can point to one very good example that actually my colleague Alistair has led on. We have built the entire supply chain for a power unit that goes into a McLaren electric sports car. It uses the semiconductors that are... It's not exactly every day, but nonetheless it's a good example. It's a good example, but also the catapult works with very innovative companies to take risky products to market faster. So naturally, we tend to work with a highly innovative company that might be a smaller volume to get that product to market quickly. But on the back of that, we then won another contract with BMW. Now, BMW is clearly a larger supplier, a larger company, but there's a natural progression here where we tend to choose sort of small innovative companies because we want to get these really risky products to market quickly, and on the back of that we can crowd in much bigger sort of volume production of those semiconductors. Okay, thank you, Chair.
Thank you. Paul Howell, please.
Yeah. Thank you, Chair. And I just want to touch on probably the argument starts with a subject we've all heard a lot of recently, which is about resilience. It doesn't matter which business sector we're talking about, and it's about where we should actually be in the UK. You know, we've seen that there's reports out there that say we shouldn't be focusing on onshoring the semiconductor industry, we'd rather play to our current strengths. Two parts of the question really. One, what do you see as our strengths and comparative advantages? But also, do you agree with that argument, or do you think that we actually should be putting a more resilient picture more resilient structure into our UK offer? And I know, Martin, we've come to you, but feel free to put it to whichever of your colleagues are most appropriate for these answers.
If it's okay with you, I'd like Alistair to answer that question, please.
Okay, thanks, Martin. Thanks for inviting me. So I think it's a very large, complex industry, and it's not just a case of one type of semiconductor. It's a very broad industry with lots of different capabilities. You can generally describe it as three main elements to the semiconductor industry. You've got the manufacturing side where they actually make the chips, and that could be silicon or compound semiconductor. Essentially, it's very similar processes. You've then got the electronic system. So if it's an electronic system, it's got a chip in it. So there's all the work around taking a chip and putting it into, creating the electronics environment or solutions for different markets. And there's UK's quite strong in that as well. And then you've also got the design side. So you've got the manufacturing of the chips, but then you've got almost a separate industry that can design the circuits that are used on the chips for electronics. So those three main areas. So then if you look at the UK capability in those three main areas, on design, you've got a world-leading UK design capability, primarily on silicon. So companies like ARM, Imagination, Dialog, and Silica, they all work on these sorts of silicon design technologies, the vast majority of which are not manufactured in the UK. They're manufactured in the Far East primarily, because the capital investment for those types of silicon technologies, if you wanted to build a new fab, so a fab is a semiconductor manufacturing site, we'll mention fab a lot. If you want to build a new fab in leading edge silicon, you wouldn't get much change out of about $20 billion. So there's none of that in the UK, that's in the Far East. However, in the compound semiconductor and older sort of silicon technologies, there's still a lot of silicon manufacturing in the UK, just not in leading edge. They still make a lot of money, primarily into automotive markets. There's UK capability there in older technology silicon and silicon carbide, gallium nitride, compound semiconductors, and there's about 25 fabs in the UK manufacturing these types of technologies, and they've been around for a very long time. Once you establish something like that in manufacturing, it takes a very long time. It's very difficult to move because it's one of the most complex processes man has ever created, is to create a silicon chip. Right? And once it's there, it's very sticky. So you've got that in the UK for manufacturing, and then the post-fab or the electronic systems integration side, there's strength in the UK, particularly in power electronics, RF microwave, sensing and comms. So again, that's primarily in you'd say the compound semiconductor or hybrid technologies. So in each of those areas, there's technology. One of the issues you have in this industry is quite often, at the moment, there was a question about the recognition within industry of the semiconductor supply chain. Quite often within the semiconductor supply chain, it's not recognised. So for example, companies like ARM and Imagination, because none of the material they use to manufacture their products is done in the UK, they don't necessarily recognise a UK manufacturing capability. And vice versa, they're quite separate. In the future, there's the opportunity to take the UK design capability and bring that together much more closely with the UK manufacturing capability as those new technologies start to mature and reach wider markets. So that's one of the opportunities. So hopefully those three areas, yeah.
Thank you, Alistair.
Yeah, and I get that. I think just to follow the question just a little bit further. So what do you think are the real potential opportunities that the UK compound semiconductor industry should be looking to grasp?
Well, I would certainly say that in power electronics, so for example, every new Tesla on the road, the power chip for that is a silicon carbide power electronics chip. And the UK's got both manufacturing and supply chain capability in that area. And that's only going to grow. The most automotive manufacturers are looking to incorporate silicon carbide in their power electronics. It then goes into all the charging, vehicle-to-grid charging. It goes into the grid. And there's a new UK fab in Fife called Classic, which is a $60 million investment, which actually manufactures silicon carbide chips and is already pretty busy and starting to grow. So, and you've got other UK manufacturing sites that have got the capability to move to silicon carbide technologies. So that's an area where the global growth, particularly driven by automotive, is very, very high. And there's material supply issues even in silicon carbide at the moment. It can take a company about a year to wait on a silicon carbide chip because at the moment volume, because of the electrification agenda, volume is vastly exceeding capacity at the moment. So there's an opportunity in these very quickly growing but relatively new areas for the UK to take quite a leading position. And that gives you're looking at security, the security of supply chain in electrification, you could argue is a pretty important area.
Thanks. And just coming back to what you said in terms of the structure, you've got your manufacturing, you've got your systems, you've got your design. But when it came to manufacturing, it seems like you were saying basically, the chips are going to be made in the Far East. And if that's the case,
one type of chip. So the very advanced node silicon chips. So if you look at primarily, say, microprocessors for automotive, for example, that is most of that's in a lot of the consumer electronics is mostly Far East manufactured in silicon. But in the UK, you've got significant manufacturing capability in non-silicon or older silicon technologies. And it's still mostly silicon in the UK, and 90% of that is actually for export. So there's still significant. So remember, a fab is, depending on the technology, the capital investment, the cost of a fab is very different. So in most of the UK manufacturing sites, it's typically 50 to 100 million to build and run a semiconductor fab of reasonable scale in these sorts of technologies. If you're in the very, very leading edge silicon technologies, then it's just exponentially higher. And the UK is not in that space. But
sorry to interrupt you. But should it be? Are we in a situation where technology is just going to run away from us?
Yes.
In a past life, I worked up in what was then the Silicon Glen, and a number of the companies that were there just disappeared because they didn't keep up with technology. And if we need to be resilient as a country, do we not need to do something somewhere somehow? Is there some, just to broaden the conversation, is there some alternative things? I mean, I'm a North East MP, and I know that we've got people talking about using diamonds instead of silica. Is there something else that we should be taking, not just the silica agenda, in terms of where we go with semiconductors?
Can I invite Andy to make a comment on that, because he has written on this particular subject, actually.
Yeah, thank you, Martin. I think it's fair to say whenever you build an electronic product, it always has 2 or 3 types of semiconductor in it. So if I take your mobile phone, the brain is always going to be fabricated in silicon. The facial recognition is fabricated in compound semiconductors, and the 5G is fabricated in compound semiconductors. And actually, the display is a 3rd type of semiconductor. It's an organic semiconductor. So whenever you're building an electronic system, you always have 2 or 3 types of semiconductor. Alistair's absolutely correct. When it comes to the silicon, UK is preeminent in the design space. When it comes to fabricating silicon, we tend to fabricate on older design processes, typically sort of 1990s or early 2000 design processes. I think for the resilience and the security piece, there is certainly an opportunity where Alistair has said we have about 20 to 25 fabrication facilities in the UK. And you're quite right, there's one in Newton Aycliffe in the northeast, several in Scotland, in Greenock, in Manchester, Oldham, Hazel Grove, etc. There is an opportunity perhaps to support those fabs to move to a more newer process and to secure higher functionality on the chips that they're fabricating in silicon. That would certainly, it's a growing market, and it would certainly make the UK more resilient and secure in that space. I think on the compound semiconductor space, we have great research base, and we have some really sort of great companies, and Alistair's alluded to Classic in Scotland, which is growing very well. I think there's also an opportunity here to support those companies for scale-up in particular. These are rapidly growing markets, and again, when it comes to resilience and security, you need a couple of elements. You need the design elements, but you also need the fabrication elements. So I certainly think there's an opportunity to support those companies in growing those particular areas. Thank you.
Okay, thanks for that. When you mentioned it, Newton Aycliffe is 2.6 and it's in my constituency, so yes, I'm very familiar. Thank you, Chair.
Thank you.
That was the note I made as well. Thanks.
Thank you, Paul. Martin McHugh, the resilience of UK assets has been in the media quite a bit recently, predominantly because of the National Security and Investment Act interventions on Newport Wafer Fab and the question around the listing of ARM now the acquisition by NVIDIA has collapsed. Do you think at the moment there is a clear message from government to the industry about what ministers think about intervention in this market and which assets it wants to protect and which assets it doesn't want to?
I won't say there's not a clear message. I think there does need to be a clear message. So one of the things the Catapult has observed at the moment is there are a number of initiatives across various departments within government. There are a number of industry trade bodies such as the Motor Vehicle Manufacturers and Traders Association, obviously lobbying the government, and we have our fellow Catapult, the Royal Academy of Engineers and other institutes actually commenting on and reviewing the semiconductor industry. And I think what that's actually presented is a situation for industry is that it's unsure where to turn within government to actually voice its opinion. So I think first of all, we welcome the elevated profile that the semiconductor and compound semiconductor industry is now getting with government. I think the next stage for us would be to try and get a unified position and voice across all of government, and I think that would make it easier then for the industry that we represent.
Do you think it'd be better for the work on semiconductors to be moved from DCMS into BEIS so it's all in one place, or do you think we can get to a position where all the departments are kind of doing the same thing?
I think it'd be great if we could get to a position where all the departments are doing the same thing. I know we have to, as a Catapult, the one thing that we have to remain clear on is our neutrality. Industry trusts us, government trusts us, trade associations trust us, universities trust us as that neutral convener. So it's always really a position for us that we have to kind of maintain that position of neutrality so that people can actually trust us with their opinions, and then we can actually convey those opinions back out. As I said, for us, it would be easier if there was a single voice from the government, even if that was made up of two departments.
And on the basis of that answer, if I were to ask you your view about Newport Wafer Fab, presumably you would tell me you wouldn't be able to give me an opinion.
So again, on Newport Wafer Fab, we have a position of neutrality. We have to think of the UK as a whole. So our view would be, and it was picked up with the fabs that were mentioned in Newton Aycliffe in Scotland, we would say our particular interest within the compound semiconductor industry across the UK is to make sure that there is actually targeted investments within the compound semiconductor industry in building the supply chain up across the UK. And that would include, Scotland, North East, South West and South Wales as well. And
I think the Foreign Affairs Committee suggested that the government should play a role in any listing of ARM and maintain some kind of, I think it's golden share, I think was the phrase they used. Would you agree that it would be beneficial to the industry if government had that kind of level of intervention around ownership or investment directly in companies?
I think it's a position we would rather not comment on at the moment. It's protecting our neutrality from an industry point of view and a government point of view.
Okay, I'm feeling generous today, so I won't push you. Paul Howell, please.
Thank you, Chair. Just going back to what we've touched on a little bit there in terms of the whole supply chain structure, and we've talked about the different bits of the business already, but just how resilient is the UK when it comes to the supply chain? Are there gaps in it? What's the structure like? Is it fragmented all over the UK, or are there clusters that are in different parts? Is it just certain things in the southwest, certain things in the northeast, certain things in Scotland? Should it be encouraged to be more, a collaborative structure, or is it just the way that it's evolved? What do you think we should be looking for there? And are there any particular gaps that we should be particularly concerned about, other than what we've already covered, obviously?
Okay, I'll start that and then pass to Andy. So yes, there are recognised clusters within the UK. The Catapult have actually mapped those out. Good examples would be we recognise a very strong RF cluster in the northeast that would benefit from targeted investment. We recognise a very strong cluster within Scotland around heavy power and satellite applications that we think would benefit from targeted investment. Certainly within South Wales and the cluster we're actually located in, and then the clusters in and around the east of England and down in Torquay in the southwest. So one of our roles is we believe that those clusters could actually benefit from having supply chains formed around them and actually connecting the various supply chains and actually making sure those supply chains are there to support those particular clusters as well. And that's one of the roles of the Catapult. I'll ask Andy and Alistair in turn to just add to that as well. And Andy's got a particularly good map of the Catapult network behind it, just shows how wide everything is. Andy, go on.
Sure, thank you, Martin. I think you're right. I think when it comes to compound semiconductors, we do have elements across the supply chain. So in design and research and fabrication, where they could do with a bit of assistance is in the scale up, particularly to address these large markets of vehicle electrification, 5G satellite communications. The Catapult, our Catapult is actually located with IQE, a world leading provider of compound semiconductors for facial recognition and 5G, for example. So we really are in the heart of that particular cluster. When it comes to silicon fabrication, as we alluded to earlier, we have very big strengths in design, but there is some patchiness. So for the high-end silicon chips, they're all fabbed in the Far East. Now the UK is not unusual in this particular situation. So when you look at all the major developed economies, the US, the EU, they all buy their high-end silicon from the Far East. We're not unusual in that particular situation. But compound semiconductors, we have good representation across the supply chain. Thank you.
Yeah, I would say that if there's one gap we've not talked about that the UK doesn't have is what we call base wafer growth capability. So obviously the fabs, they do all the action happens on the very top surface or epilayer of a semiconductor wafer, and Andy mentioned IQE, so they're world leading at developing that epilayer, and then it goes to a fab. But the epilayer is built on usually a 6 or 8 inch diameter wafer of different types of material. There is absolutely no UK capability in that space, so that's always a supply chain gap. And in some cases, you could argue that it would be good to have some UK sovereign capability. I think particularly in things like silicon carbide, which is very difficult to grow. But that's a definite gap. The closest to it is our company in Livingston, Shinetsu, who are the wider global company grows silicon wafers, but in Shinetsu, again, it's epilayer. So that's one gap. In terms of the cluster, so yeah, I think historically you've ended up with fabs all over the UK, but there are clusters which you can pick out and develop. So in the northeast, you've got 26 in Newton Aycliffe. You've also got a little company called INEX, which is the old Newcastle University fab that's looking to move, expand and grow. Both of those have two of the base technologies for future RF chips, gallium nitride and gallium arsenide. And then in Scotland, you've got, there's a sort of national focus on energy, hydrogen, high power HGVs, and that goes well with the silicon carbide capability that's being developed. In the southwest, you've got Plessey doing LED development, and that fits very well with the southwest sort of photonics cluster. So you can see where there are at least centres of gravity, but there's always exceptions to the rule as well. But you can certainly build around supply chains around centres of gravity to grow those new supply chains.
Okay, and just a final sort of question onto that. We talked about we could invest, we could do this. What sort of support do you think is appropriate? Is it a private sector thing? Do we need some government intervention there? Is there some sort of incentives? Or will the market take care of itself? What do we need to do to make sure we try and fill those gaps as time goes on?
I would say certainly we've talked about targeted investment to help. It's got to be industry-led. So there's got to be the will from a company to establish these very complex, high-cost capabilities. That's got to be there, but incentive-based, into say, research or just to help, perhaps capital investment to improve capacity, for example. You've got those 20, 25 companies in the UK have been there for a long time, a lot of them, and they make a living. They do quite well, but there may be some targeted investment to help them grow and scale or adapt to new technologies. The sort of innovation help that would help these companies. If you're looking at the sort of high-end silicon, the only feasible way to move into the really the 20 billion level is to be able to attract inward investment, where you've got one of the big companies like TSMC, for example, or Global Foundries, with the UK making the case that it would be good for them to build a site and invest in the UK. It's not something you can start from the ground up. It's just too complex. It takes years to develop a fab in the semiconductor technology. Even the new one I talked about in Fife, with silicon carbide, that's taken them 4 or 5 years to get to where they are. It's just early production. So it's very complex. So you need to have industry-led investment with some help to incentivise.
Thank you very much, Chair.
Thank you. Mark Pawsey, please.
Chairman, just a quick one. We've heard that this is an industry with lots of collaboration and we've got clusters, but Alistair's just told us that there's some areas with no UK capability and it would take a massive amount of time to develop our own capability. What potentially exists for international collaboration that we could work with some of these dominant players in the Far East? Can we work with them to establish domestic manufacture in the UK?
Sorry, go ahead.
Sorry, I was going to let, if that was okay with the committee, let Andy have 2 minutes on that, because he's done a lot of work with international collaborations for us, actually, and then Alistair, you can pick it up. And thanks.
Yes, thank you for the question. I think it's right. I think actually it's very difficult for any one country to have a complete sovereign capability in everything. And the integrated review, which was published in 2020, gives us a really good framework about how we should go about collaboration. So the integrated review talks about own, access, collaborate. And own is where the UK has research and fabrication capability and supply chain capability. You can own an area. And arguably, I would say that we can own the compound semiconductor area. The collaborate is where the UK has parts of the supply chain or parts of the technology, but we still need the technology. So perhaps the collaborate is where we get the higher end silicon. And then the access is where we have less of that. We need to sort of get access to.
And are those discussions taking place now?
To a certain degree, yes. So I've been out to Taiwan and I've also been out to India. Now, the thing about these partnerships is you want a trusted partnership. You want and equally the EU and the US. So I shouldn't just highlight, I should highlight the US, the EU, India and Taiwan as being trusted partners where they have complementary technology to what we have. And they are also doing quite large-scale investments. So Taiwan is really the home of the high-end silicon fabrication. India is looking to incentivize companies to grow high-end silicon or medium-end silicon fabrication. So we can partner with these countries. We're having sort of intermediate discussions with them at the moment. The US has announced the CHIPS Act in order to become more self-reliant on high-end silicon production. And the EU is also investing heavily in this space.
Okay, thank you. Thank you, Chair.
Thank you. And lastly for this panel, Alan Brown, please.
Thank you, Chair. Just moving on to compound semiconductor demand, just wondering if somebody could explain how much of what's made in the UK is actually used in the UK as an end product, how much is exported, but also then how does the export value compare to the amount that needs to be imported because of the high-end stuff that comes in from the Far East?
Do you want to take that, Andy, or do you want me to take that?
I'll have a start if that's okay, and then perhaps you can chip in, Martin. Certainly IQE is a world-leading provider of compound semiconductor EPI wafers, so my understanding is they export a large proportion of what they do. I'm also aware that in 2005, Piltronic in the Northeast exported nearly 300 million compound semiconductor devices to the US for the mobile phone industry. So we do have some sizable sort of market exports in this area, but equally it's a global market. So we're not just supplying the UK, we're supplying into a global market. Thank you.
Okay, and I was just going to say, just for some reference numbers, that some of the numbers we have is the world market for compound semiconductors was around about 32 billion in 2020 and expected to grow to about 43 billion in 2025, and the UK market would be about 7 billion. And what I wanted to add then is that within the cluster here in South Wales, 95% of the output of the cluster is actually exported, because it's not just for electric vehicles, it's for mobile phones and other devices. So yeah, I hope that kind of answers your question.
Yeah. Okay. Just one kind of final question. I think it's probably for Alistair. How do you envisage the demand for compound semiconductors will change in the future? And is the UK capable of meeting that demand? Now, we've already heard different things about industry needing our government speaking one voice, need inward investments. What would be the kind of key ask then, just to make sure the UK is well placed to meet that future demand?
Yeah, I think there's probably three elements. So compound semiconductors are still relatively new, so there's an opportunity to grow in those areas: power electronics, communications, sensing. So where we would see probably the three main likely interventions there is, one is selective targeting of semiconductor manufacturing investment across the various capabilities in the UK. The post-fab, the electronic systems side, there's existing capability there. And he talked about the project we've done where we've developed a supply chain that goes up through to McLaren and now BMW in power electronics. So bringing that industry together in electronic systems integration is important, because again, there's bits of IP all the way through up post-fab. When you're putting the system together, that's where we stand. And so in both silicon and compound semiconductor technologies, that's important. And then the third area is really exploiting the great design capability we've got in the UK. So as the compound semiconductor technologies become more mature, they move to they could be more generally used by designers and solution providers in electronics, and that's where the design community can come in. As that becomes more commoditized, then more accessible, then the UK design capability is potentially a good position to sort of start to work much more closely with the UK manufacturing post-fab supply chain than it's done previously. And that's more a sort of industry networking and integration challenge, I would say. But those would be the three areas.
So
and then you're positioning yourself. Yep.
How would that collaboration early enough in the process come about to make that much more coherent and then create these additional jobs? We can give some examples. I think developing products and solutions, even at an innovation level, to bring the supply chain together into collaborative projects works well. We've seen that happen in power electronics. We've seen it in RF. So an example would be this, the project called Escape, which we helped. We worked with the UK industry to develop. So that's a 12-partner end-to-end supply chain in silicon carbide power for automotive. It started with IQE in South Wales. Moved, the fab was in Classic in Scotland. Several different packaging companies around the UK, and then Turbo Power Systems in the northeast doing a solution. McLaren applied doing a solution. So you've then got a demonstrator of a full UK end-to-end supply chain with product, and that exercises the work. It's not creating a hermetically sealed supply chain. What then happens is those companies can then go and work with whoever they want globally. They're showing what they can do, and then you're creating that capability. And then other companies can start to be partners within that. So you're not just creating one supply chain, you're creating width to the supply chain and having 2 or 3 fabrication capabilities or 2 or 3 design capabilities. And that's what gives you strength in a cluster, not just one thing. So I would say that would be a very good way to go
as you look at those new technologies, encouraging supply chain collaborations.
Okay, thanks.
Thank you, Alan. Thank you to Martin McHugh, Alistair McGibbon and Dr. Andy Sellers for your contributions this morning. We're very grateful. We're now moving on to our second panel. On the screen, we'll be welcoming Alan Banks, CEO of TechWorks, John Docherty, the industry expert at TechWorks, and Jillian Hughes, who's the director of the National Microelectronics Institute. I think we have two of the three witnesses. Who are we missing? I can't see the names on the screen.
Jillian and John. There.
We've got Jillian and John. Have we got Alan? Oh.
Here he comes.
And there you are. Hello, Alan. Good morning to all three of you. Right, we're going to kick off with Mark Palsey, please.
Good morning, and thank you for joining us. One of the reasons why we're doing this inquiry is that we know that some UK manufacturers are suffering because of the shortage of semiconductors. In fact, before I came to this meeting, I attended an Industry Parliament Trust meeting where a major vehicle manufacturer mentioned that they had to stop the production line because they hadn't got the components they needed. So can you tell us the nature of the problem and how it's arisen? And is it an issue that's exclusively affecting the UK, or is it a worldwide issue?
Okay, good morning. Thank you for giving me the opportunity to speak. To answer your question, it's a global phenomenon. It's not something that's just happening in the UK, and it's not just affecting the automotive industry either. The reason the automotive industry is seeing it is it's a very large consumer of electronic devices and semiconductors which go into those devices. The worldwide shortage has really been caused by a change in the schedule. So as a result of the pandemic, a lot of the automotive companies were reducing their schedules because the demand for new cars was going down because people weren't able to buy them because the dealerships were closed and so on. So the manufacturers actually changed their schedules, and at the same time, as a result of the pandemic and other effects, there was a rise in demand for consumer electronics. So people were working from home, so there was an increase in demand for laptop computers, desktop computers, video machines, gaming machines, and so on. So the consumer electronics industry started to fill up the capacity in the semiconductor pipelines that the automotive guys were typically using. And of course, then when the pandemic started to come to an end and the supply chain started to move again, there was no capacity left for the automotive guys to be able to put their schedules back to what they were. So they kind of went to the back of the queue. So what we've seen is quite a change in the dynamics of the way that the semiconductor industry is affecting the industry. So yes, it's very much a global phenomenon. It's not just affecting automotive, but they are by far one of the biggest that are affected. And it will continue to do so. Our expectation is that the semiconductor shortage will continue through 2023 because the worldwide capacity just isn't there. And as you saw with some of your previous speakers, some of the chips are coming out of the UK. In fact, the UK does supply quite a large number of chips into the automotive industry. But the automotive industry is very much a global industry and takes its semiconductors from all around the globe. So it's very much a worldwide phenomenon, so it's not just a UK problem.
Okay, you're suggesting that automotive have made the biggest noise because they're one of the biggest users and it's more evident there. What other sectors in the UK are active consumers of semiconductors?
So anything that is manufactured in the UK which has electronics associated with it. So it could be medical devices, it could be aerospace devices, it could be consumer devices, automotive as well. So it's a large different. The reason the automotive probably makes more of a noise is because it's a bit more specialised in terms of the use of the semiconductors. So not every semiconductor is the same. Although it may provide the same function, it's not the same. If you think in an automotive environment, the semiconductor has to operate in very, very high temperatures. It might be sold in Arizona, for example, or very, very low temperature. It might need to be sold in Finland. So those semiconductors have to be qualified for very, very extreme operating temperatures. So where you've got semiconductors that are very specialized, that's why sometimes those are more constrained than some of the other semiconductors, which may have more of a natural drop-in replacement. So it may be that you may be able to change one semiconductor device for another semiconductor device and have the same function. But if it's being qualified for a specific environment, it may not be so easy to swap these components in and out. And I think that's probably why the automotive industry is being hit the hardest, because of the specialist nature of the semiconductors that they use.
Okay, so you've spoken about the lack of interchangeability of the components. Do we have any estimate of the cost to British industry of the shortage of supply that we've experienced over the past year or so?
I don't want to put a figure on it because it would have an exposure of some. I mean, all I would say is one missing semiconductor can stop an entire vehicle production in a manufacturing plant, and each plant is manufacturing, maybe hundreds of vehicles a day, and some of these plants have been stopping for months on end.
Okay, you've told us it's also not just vehicle manufacturers, other components. Do we have a sense of the financial burden that businesses have had to bear through lost production because of the failure, if we might describe it that, of this industry to provide an essential component?
It's extremely high. I can't give you a number, but all I can say is extremely high. You can imagine that if any company that is producing very high value products is unable to sell its products, then it has a significant impact on that business.
Is there anything that government might have been able to do to assist UK manufacturers to get their hands on these scarce components, which maybe have been scooped up by manufacturers in other countries?
In all honesty, I don't think it's anything that government could do because it's about the size of the market. So even though automotive is very high hitting, it's a very, very small percentage of the number of semiconductors that are sold around the world. So if you're a semiconductor supplier, you are going to supply to the guys that have the highest demand from you. So even though the semiconductors are going to high value products, which is a car. Okay,
so have our manufacturers missed out in relation to other manufacturers who are maybe bigger and more clout around the world? Have they managed to get hold of these things in a way that ours haven't?
Other automotive manufacturers?
Well, in any sector.
Not particularly. Some industries, as I said, so the consumer electronics industry has huge volumes. So the semiconductors are typically going into those companies which have very, very high volumes. So that's what we're seeing is much more semiconductors are going into the high volume manufacturers because of the scheduling. They can schedule very, very high volumes.
So we wouldn't have got more if we'd shouted louder or paid more.
No. And talking to my contacts in the industry, we've got very, very senior people in very, very large automotive companies knocking on the door of semiconductor companies, and they're not getting an audience because the volumes are not big enough.
All right. Okay. Thank you, Chair.
Alexander Stafford, please.
Thank you very much, Chair. I really want to find out what are the major challenges facing companies in the industry today, and what are the upcoming problems? We've already talked about what the current problem is and where it's going, but are there any other upcoming problems, stumbling blocks, which you can see in the next year or 18 months, which I haven't really mentioned?
Can I just qualify your question? Do you mean in terms of semiconductor supply, or do you mean in terms of the industry in general?
Semiconductor supply, sorry.
Okay. The biggest thing that we're seeing at the moment is an impact of raw materials, predominantly by the situation going on in Ukraine and Russia. The development and the creation of semiconductor materials requires a lot of inert gases and very high and noble gases. Many of these gases are coming in from Russia and Ukraine, so we are seeing constrained supply of some of these raw materials. So I think we are likely to see a continuation of semiconductor shortages beyond the scheduling issues that were caused by the pandemic as a result now of the conflict that's going on in Ukraine. So we are likely to see an impact of that on the supply chain.
Just on the inert gases, can you give us some sort of scale of how big a problem this is? And is there a store in the UK and it's about to come out, or is it already having an impact? What percentage of the inert gases come from Ukraine, Russia, semiconductors?
If you don't mind, can I ask Jillian to answer that question, because she's previously commented on that on the radio.
Hi there. Good morning. Within the UK, I mean, one of the issues that was highlighted recently was neon gas. But within the UK, neon is not a process gas. It's actually a gas used in the lasers which etch the pattern onto the silicon device. So impacting from a UK perspective, it's not that high in respect of neon gas, but there is countries in the world landscape that use a high percentage of neon gas coming out of Ukraine. So we may have supply issues, worldwide issues there. In relation to other gases and raw materials that are used in the semiconductor industry, not just from Ukraine and neon, but for example, hydrogen gas, which is a process gas which we don't have an abundance of here in the UK, we actually import it in. So we are looking at supply chain issues within the semiconductor industry. I think you have to look at the whole market. We don't have a full supply chain. When we talk about supply chain, we're talking about design, manufacturing, packaging. I think when you look at the manufacturing side and the equipment and the raw materials that go into actually produce a silicon chip, we don't have a lot of the materials or gases here within the UK, so we are heavily reliant on supply chains worldwide.
Okay. So just to clarify that, so you're saying in the UK we don't really have any examples of end-to-end supply chain for semiconductors. We are so reliant on the international markets in the world, is that correct?
Yes, that is what I'm saying. We don't have end-to-end supply chain. I think it's very difficult to actually say we'll have end-to-end supply chain for the different types of semiconductors that we actually make here in the UK, because they're all different and they all use different base materials, use different processes. So you would have to actually break it down into each technology area or each device to look at the supply chains independently. But if you look at the UK semiconductor industry, I would say the majority, 80% maybe, of the processing of the technologies, whether it's compound semiconductors or whether it's a silicon chip, the tool sets are predominantly the same. It's actual process steps that are different. So it is very, very complex. So you'd have to break it down into each of the different areas to look at the supply chain, look at the gases used, look at the materials used, look at the chemicals used.
Okay, I mean, obviously for us that's quite a worry, especially as we know what's going on in the international stage at the moment. Are there any ways in for UK companies which are not fully exploiting what we do have in the UK supply chain? I obviously hear what you're saying about the majority well, we can't have an end-to-end supply chain, but if you say we can have certain parts of semiconductors or certain aspects being made in the UK, are we fully exploiting what we have in the UK? Is there any more room for that, for growth in the supply chain? Or are we just stuck in international markets and that's it? It's basically what I'm trying to ask.
No, I mean, I don't think, we've not seen any issues with the supply of gases within the UK, but very few. We have to wait until industry tells us of the issues that they're experiencing. But if you actually think throughout the pandemic, the biggest issue has been basically capacity. There has been a few issues where companies have long lead times on basically raw materials or gases coming into the country. But I wouldn't say it's had a massive impact. We've still managed to reach our output and our KPIs, but it's just something to be aware of in the future when we're looking at basically what Andy picked up on the framework of own access, collaborate. We have to be aware that we do have to have relationships out with the UK to ensure a steady supply chain of materials, gases and other things used in the processing of semiconductors.
And obviously we've talked about this global supply chain for this global ecosystem for semiconductors. But in that whole ecosystem, what parts of it does the UK do particularly well in regards to semiconductor? Is there any aspect that we are proud of and that we are world leaders?
Yes, silicon design and basically advanced nodes. I think we're world leading. Our R&D, especially on the new materials, and I think it was touched on earlier, graphene, compound semiconductors, diamond. And I think we have excellent know-how. I think we have excellent skills and knowledge, albeit we are reaching an ageing population where we're going to experience a skills issue and a skills gap. But I think the know-how and the experience we've got here in the UK, which has came from probably the 70s and 80s and 90s, where we had Silicon Glen, I don't think that has to be ignored. I think we have to build on that.
Just a bit more on that. So you said you want to build on it, and we have a skills gap. How can we build on what we've got, and what particular skills are lacking in the UK, and are those skills available in other countries, and that's where the market's going, or do we need to train more people in the UK?
I think we have to build skills in all areas of semiconductors, design and engineering. I think we have to increase the content of semiconductors in some of our electronic engineering courses. We have a great charity here called UK Electronic Skills Foundation, who do an absolutely fantastic job. I think we have to scale up foundations like that to help address the needs and skills of the industry. I think as well, I mean, apprenticeships and graduate apprenticeships are absolutely great, but what we are experiencing within industry is the administrative burden for actually taking them on, and because we are reaching an ageing population within industry, there is a shortage of experienced design engineers or equipment engineers or process engineers within the industry themselves to actually, although companies would like to take on more apprentices or more graduate apprentices, are struggling because they have to provide hands-on training in that environment as well. So it's having a knock-on effect. Would they like to take on more younger people to bring through the industry? Absolutely, but do they have the bandwidth to do it? They don't at this moment in time. So I think we have to look at the content and the engineering courses, and we have to make it more attractive. Do I think we can get students in from abroad? Yes, we can, and I think you've already looked at the kind of visa requirements to actually make it more attractive for engineers to come in. But the problem we have is, can we retain those engineers within the UK once they're qualified and once they're here? And I think that has to be looked at.
Why can't we retain them at the moment, do you think? Is there better money elsewhere?
Other countries then become more attractive.
I mean, is it financial wages basically, or is it other aspects better? I don't know, work-life balance or better research? Or what is the main pull to other countries?
Probably life-work balance, salary. I think a lot of people are basically motivated by salary as well, but it just depends on individual circumstances. But I think a lot of students are coming here and being educated here at our universities, going into industry and then maybe leaving to go back to their home country.
And are there any particular countries, would you say, which are our rivals who are pulling our students which we've trained up to them? Is there any particular countries we should be wary about?
I actually don't know the answer to that, but I don't know if John may be able to answer that.
You're on mute, John. While we're trying to unmute John, maybe Alan, you want to say a few words on that?
Yeah, so, I mean, I would say that the United States is probably one of the most attractive. Typically, we would see, I mean, given the option of working in London or California, some people would prefer to spend time in the sunshine. But the wages that are offered, particularly in the US and some other countries, are more attractive than what a lot of companies can offer in the UK. So, as Jillian says, it does tend to be wage-driven in many cases. But it's not just about the wage. I mean, what we're seeing is that we're seeing quite a lot of international students coming into universities, and the universities welcome them because they're typically higher fee paying than the UK nationals are. And the courses that we offer are good. And then what happens is these students typically over time will gradually migrate back to their home countries. So we lose that skill that was created in the UK. But it's also true in some of the countries. So for example, when we create intellectual property in the UK through our design activities, we're not doing enough to retain the intellectual property in the UK. And what's happening is that over time we are seeing acquisitions of small companies because they're struggling financially in the UK, and we lose some of that intellectual property overseas. So over time, some of this skill set and intellectual property gets eroded.
Thank you. John wants to jump in.
Sorry, I was going to try and speak now. Sorry. The attractiveness of technology and advanced technology, deep submicron, is massive to the engineering community. Design across the board in manufacturing. And equipment guys will locate in other countries. That attracts a lot of our people. You can go anywhere in the world and meet UK talent. who've left the industry in the UK or started somewhere else. And the big investment that companies like Intel make in Ireland and other companies are making in the USA right now, massive attraction for the young graduates coming out of the UK.
Thank you. Thank you, Chair.
Thank you. Paul Howell, please.
Thank you, Chair. Just a similar sort of question, I guess. It was just a slightly different subject. Rather than talking about skills, we're talking about facilities. You know, in terms of just where does the UK sit? You know, are we batting above our level? Are we about where we should be for a country the size of us? You know, are we? You know, can you just try and give us a sense of what we should be doing?
Can I take that one? So the UK is a very, very good country to actually create a silicon environment. We have a good climate. We are surrounded by water, which is very important in the manufacturing process. We have a stable government, and we have very good environmental conditions. We don't typically have earthquakes or other environmental impacts that some other countries around the world. And we've seen the impact of some of these things on various natural disasters that have happened over the last few years, particularly in Asia. So the UK, geographically and politically, is a very, very strong country to base ourselves. So that's the first point I'd just like to make. So I think as a country we need to make more of that, and we need to be singing and praising our country of where we sit in the world, both geographically and politically, and trying to attract more inward investment to that. In terms of where we are on the global stage, we're tiny. The global semiconductor industry is worth about, in 2021, it was worth about $550 billion US in sales, and that's expected to increase to about $600 billion in sales this year. We're about 0.5% of that, so we're tiny in terms of the size that we are. As we said earlier, we've got about 25 manufacturing facilities in the UK, but we don't provide finished goods out of those factories. What we tend to do is we would we would import some base materials. We would then do some initial etching, as Jillian said, and some other basic functions. That then goes offshore to be finished into another product, to be packaged. Then it will come back into the UK into another product, which may end up into an automotive application or a power application or whatever that may be. So to answer your question, where do we sit on the global stage? In terms of our capability, very, very high. In terms of our actual footprint, it's very, very low at the moment.
Okay, it sounds a little bit of a conflict there in terms of, you know, you're saying that we're a good place to do it. We've got a lot of opportunities and resources and the right environment, you know, whether it be political or physical. So how do we get it to move forward from there? You know, we've talked in the previous session about, you know, the UK and where things are fitting, but how do we get ourselves into a better place, either fitting better into international supply chains and doing things differently, or collaborating with partners, or, you know, why isn't things going better, stronger and faster in the UK?
So we think, to be frank, I think what we need is a UK semiconductor strategy. And we need to be very clear on what products that we can do here and what products we probably will never do here. As the previous speakers have told you, the cost of investment to create one of these factories is enormous. It's really, really high. So it's very, very, very expensive to create a manufacturing facility for semiconductors. So you have to have a company that has the capability to invest in such large manufacturing scale. I think we probably talked about earlier that Taiwan has TSMC, which is the largest fab in the world. We don't have anything like that in the UK. But what we do have is a lot of legacy, small but legacy fabs, but they do produce high quality output, but they're really niche applications. So I think what we need to do is map out what the product's requirements are for the world, and agree what products the UK should be really focusing its effort on. And then the UK government and industry get behind this strategy to say, these are the products that we're going to support. These are the ones that realistically are affordable for companies to invest in the UK and for the government to support, to create these industries and keep them going. And then we can continue to have our presence on the global stage. We don't believe that it's feasible to ever create something like TSMC in the UK, because frankly the UK government doesn't have the money to invest in such a large investment, and we don't have companies who are coming into the UK because they're not really being incentivized to do that. So I believe that we need a strategy. We need to be clear on what the products are that we're going to focus on, and then we need to get behind that, both government and industry, collaboratively to work together to make sure that we move this forward and create an environment that is there for the long term. That, you know, this is not a short-term fix. This is investment for the future, for our future generations, and to try and, you know, really sustain economic growth, job creation, and employment for our children and our grandchildren.
Okay, and just to take one. Sorry, Jillian, do you want to add in first and then I'll come back to the next one?
Can I add to that? Talking about where our strengths are in the UK, out the 25 fabs, and I know that the focus was on the compound semiconductor side in the previous session, but we're also very strong in silicon. And although we don't have leading edge silicon manufacturing here in the UK, but if you actually look at recent reports, over 50% of silicon chips that are manufactured are above the 180 nanometer node size, and that's exactly where we play into in the UK. We don't have to have leading edge node size in the UK. If there's a market case for it and there's a business case, then absolutely, why would we not look at it? But we can play into the markets that we're actually strong in just now, and we can scale them up, as Alistair etc. says in the previous session, with targeted investment. So if we're looking at the net zero agenda, not every single chip that goes into an automotive vehicle, an electric vehicle, is going to be a compound semiconductor chip. You still have to have the silicon, you still have to have the other. So in the UK, we are strong in photonics, sensing, comms and power electronics, and we're looking to scale up the photonics sector, the compound semiconductor sector. And if you look at Classic in Scotland, which I think £60 million to build, with £20 million investment, they can treble their production capacity. So it's just to give you an idea of what the value of investment is to triple capacity. So we go from low capacity to medium in the compound semiconductor space, which is feeding into the net zero agenda as well for electrification of vehicles. So I think it's to put that into perspective as well, that we don't need leading edge node sizes. We have got niche markets here in the higher end mature silicon as well.
Okay, no, thanks for that, Julian. Thanks for that clarity. Just to develop that thought a little bit further, one of the things that we all have been concerned about over the last year in particular with Ukraine and previously with the pandemic as well, is about UK resilience. So are you saying that in terms of the partners that are out there where we can get supply from the more leading edge pieces, and that there is we've got the partners that are producing are ones that we would class as being, you know, there, and for want of a better phrase, friendly in the long term, that we would see a worldwide resilience to our supply chains?
Yeah, I mean, we are dependent very much on, as we said earlier, we don't have an end-to-end supply chain. So we are very much dependent on raw materials and other elements from around the world. We believe that, again, this is part of a strategy. We need to make sure that we're aware of the geopolitical situation. We are very, very nervous about TSMC because of its position in Taiwan and the potential threats that it could face. And if TSMC was to lose its ability to supply chips around the world, it would take 3 or 4 years for the whole world to be able to create what comes out of Taiwan. So that would cause a massive shortage. So we need to be aware of where our chips and where the raw materials are coming from. So we need to be very clear on what the supply chain is. And as we've mentioned earlier, you know, we've got conflicts all around the world. We've got different elements coming from all around the world. What we need to do is be very clear on those countries that we want to partner with, that we have strong political ties with, as you said, friendly nations that we want to be able to secure. But that needs to be very much written into contracts that says the UK needs to be able to secure a supply chain particularly for semiconductors that are going into communications infrastructure, power infrastructure, those infrastructures that are national national requirements for the country. Some of these things are absolutely critical, and in some cases there may be some vulnerability in the supply chain, and we need to do some research to make sure that we fully understand where all of those raw materials are coming from for products that are coming into the UK, and what the potential impact could be. So effectively a disaster recovery plan needs to be put in place. So in the event that we do see issues with a particular supply or a particular country that provides supply, that we have alternative supply routes in place.
Thanks, Alan. Just one very final question. Obviously, semiconductors are important, but is there something coming that's going to replace them? Is there something out there that we should actually be stepping ahead of the game on? Is there a different type of supply, different type of manufacture that could just, we all see industries that have just risen and fallen and gone away. Is there something else that we should be aware of that's going to come into this space, or is that just far-fetched at the moment?
Who knows is the honest answer.
Okay.
We don't know what we haven't discovered yet.
We don't know what we don't know.
What we can say is, even with the advent of things like artificial intelligence and all of the new computing technologies, all of this requires some form of electronics to run on, and all of those electronics require a semiconductor to provide the underpinning circuits that are required to run it. So even at the cutting edge of technologies that we're developing now, there's still a requirement today for some kind of conductivity device, whether it be a semiconductor, a compound semiconductor, a diamond, or whatever the material used for that connectivity is. At the end of the day, it's connectivity. They're all just tiny little electronic circuits that are getting smaller and smaller and smaller.
Okay, thanks, Alan. Back to you, Chair.
Thank you. Just a final question from me. So we've heard the evidence from you today that, and from our previous panel, that there should be a new kind of overarching strategy from government on semiconductors. There should be a disaster recovery plan if, for example, exports from Taiwan become constrained because of geopolitical issues. We're observing that the government here is intervening much more around national security assessments in different parts of the supply chain and assets that we have in the UK. Just lastly on that piece around the national security assessments, is that increasing or decreasing confidence for investment in the industry in the UK? Or is it too early to know? John, sorry, you want to?
Yeah, I think it's too early to know. I think I don't think people that would want to put money into the UK, that would be the prime requirement they would consider. And they would look at multiple supplies and then see how they can ring fence the security aspects of that around that. But again, I'm not an expert in that space. It's just my thought on that.
And just in the final minute, just for my understanding, Alan, you said that the production capacity in Taiwan, we would never be able to rebuild that in the UK without spending a huge amount of money, and that there's a concern around exports being constrained from that site. Where else would we go if we couldn't get it from that site in Taiwan?
I mean, Japan and Korea have similar size facilities, but the TSMC out of Taiwan is the dominant one at the moment. We are seeing the rise in others. And the European Union have just invested a significant amount of money in their semiconductor strategy. So within Europe, we're seeing the European Union start to invest quite heavily in the growth of semiconductor to try and offset some of these issues, to try and create capacity elsewhere in the world. So it's a dynamic situation. The current situation is TSMC are dominant in the market, but there's no reason to say that can't change as other countries invest heavily and other companies invest heavily to try and increase the capacity around the world, which is what we need to see. We need to see that diversification and ability to have a sort of a contingency around the world.
If I could just enlarge on that a little bit. TSMC are now diversifying outside of Taiwan. They've diversified inside in different locations. Singapore is now regaining prominence. It stopped investing a number of years ago, but it started reinvesting heavily in wafer fab capacity. And so, there's an awareness of the cluster that's in Taiwan and some of the political vulnerability that goes with that.
Great. Well, thank you for that, and to all of you for your contributions this morning. So Alan Banks, John Docherty, Jillian, Hughes, thank you so much. We'll now call the session today to an end. Order, order.
Thank you.
Thank you.
The proceeding has ended. 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 The proceeding has ended.